My name is Rafal Kocielnik, I'm a postdoc at Caltech, and today I'm presenting our work on the limits of LLM adaptability when we investigate how model internal priors affect annotation task performance. This work has been done in collaboration with Etienne Casanova and Michael Alvarez at Caltech, and with support of LCSSP. So the motivation here is that LLMs are increasingly used as convenient annotators when they are labeling a large amount of data at scale with limited or practically no training. Now they can do that because they have learned a lot of information about text from its internal training data, and they can apply this to interpret different definitions. Now the challenge here is that when we give an LLM a definition, does it really follow in this case our definition or its own internal concept? To investigate this, we try to answer three connected research questions. First of all, does model definition and data familiarity predict performance? Can better prompting rescue any kind of zero-shot mistakes that come from misaligned internal priors? And can model confidence tell us when it is using a misaligned definition? So can we diagnose whether misalignment happens? So in order to answer these questions, we are actually investigating 8 data sets across 4 domains, including social media, gaming, news, and discussion forums. And this is really important because we can look at different surface level word use and also different definition applied by different human annotator teams. With this definition contrast, we can test really different definitions of hate speech, toxicity, and other concepts. Now, to answer the first question, we first want to collect how LLMs behave in a zero-shot task when their performance is just determined by its internal definition. So the LLM is given a text content to annotate, in this case, for example, for toxicity, and it really needs to apply its own internal definition of what toxicity really means. With this, we measure various LLM families, including Llama, DeepSeek, and Gwen. We can, to really answer a question about familiarity, we quantify familiarity on the task familiarity level when we introduce our own metric called definition-specific familiarity, or DSF, which intuitively just captures whether the definition the model has is really aligned with the definition under which the dataset has been labeled. We also measure dataset memorization metrics both at token and semantic level. We find that DSF predicts accuracy in annotation tasks with a correlation of 0.4. However, text memorization surprisingly does not. It's even slightly negative. This really shows that task familiarity is important in annotation performance, whereas it's just simple memorization of text is not. For the second question, we want to see whether whatever mistakes the LLM made, whether better prompting can rescue the zero-shot mistakes. We compare our baseline to adding additional knowledge, so essentially making better prompts, adding task knowledge, aligned definition, few-shot examples, combinations of those, as well as optimizing the prompt using automated frameworks such as DSPY, as well as multi-turn correction. We find that the zero-shot mistakes are actually quite stubborn. Overall rescue rates of ability to correct zero-shot mistakes with better prompting is around 35%, and high confidence errors are indeed the hardest to fix, which kind of makes sense. For the first question, we want to investigate whether confidence diagnose definition misalignment. So if the model is very confident, does it show, for example, that it is better aligned? So we provide aligned definition where the data set has intended labeling policy. We also provide, thanks to our various data sets and various definitions, we can do concept substitution when we provide misaligned definitions that are narrower or broader or completely alternative to the concept under which data set was labeled. We find that LLM indeed shift behavior with the definition in expected ways, such as that narrower definitions cause underprediction and broader definitions cause overpredictions. At the same time, models are happily, confidently applying both aligned and misaligned definitions with confidence showing really no indication of it. In conclusion, we showed that LLMs are not neutral labeling machines. Definition alignment matters, prompting has limits in correcting mistakes, and confidence levels can be misleading. Practical guidelines include measuring definition alignment before annotation and always checking performance against ground truth.